Welcome to the Analysis Research Service Center Olympus FE3000 Laser Scanning Confocal Microscope video series. In this video, I will discuss how to optimize resolution in X, Y, and Z utilizing the Confocal software and Nyquist sampling. Please remember to follow all ARSC policy and procedures and use the Confocal standard operating procedures. In the Olympus Acquisition software, navigate to the Information tab, which is located on the bottom left-hand side of the window. In the first section, you will see it says Pixel Size. Pixel size is defined as your field of view, determined by your objective magnification, chopped up into the number of pixels you specify in your aspect ratio. You can alter the pixel size by zooming in. This makes the pixels smaller, squeezes the pixels closer together. The key to seeing the smallest possible thing is making sure you sample more frequently than you want to actually see. For example, you have two actin filaments that are 300 nanometers apart. If you have pixels that are 415 nanometers wide, those actin filaments fall under the same exact pixel and will look like one green square. You'll not be able to differentiate between the two. The key to resolving these two actin filaments is to sample before the filament, on the filament, between the filament, on the second filament, and after the second filament. You have to set the sample rate at twice the frequency of separation in order to see the separation. This is called Nyquist sampling. Different groups have different ways of calculating this. In an engineer's world, they say to take your desired separation and divide by 2. That will be sufficient in most cases. In the optical purist world, you will take your desired separation and divide by 2.3. So, for true Nyquist sampling, we are going to take our desired resolution and divide by 2.3 and adjust our pixel size accordingly to achieve that level of resolution. To maximize the resolution, we're going to look at our optical resolution value in the information panel. This will determine the smallest possible object you can resolve. Next, we will adjust our pixel size through zoom and/or aspect ratio to get our pixels to 1 divided by 2.3 times the optical resolution in X, Y, and Z. Let's do an example. Here our optical resolution value for X equals 0.1645 microns and Y equals 0.1645 microns. Divide these values by 2.3 equals 0.071. Increase the digital zoom value until you achieve this value for pixel size. In this case, it is a 2.91 times zoom. Please note, if you want to change to a different aspect ratio, you will need to have a larger zoom. Alternatively, the software has an optimize button for you, which automatically does the math dividing by the close enough value of 2. To calculate the same for Z, in this example, our Z equals 0.7625 microns. Dividing this number by 2.3 yields 0.33. This means you will want your step size value to be 0.33. You can edit this by typing in the value, or alternatively, the software has an optimize button for you, which automatically does the math, dividing by the close enough value of 2. This automatically changes the step size value for you. Please contact ARSC staff if you have any questions.